Hello and welcome to the Acumentrics NPlus Senior Project presentation. The team composition consists of electrical engineer Rute Gidey, as well as myself, Nathan Chofay, and I'm also an electrical engineer. We are also accompanied by technical directors Brendan Schmierbeck and Mike Majdalani. Acumentrics' headquarters is located in Waltham, Massachusetts. They are the trusted market leader in RUP since 1994. RUP stands for Rugged Uninterruptible Power Supply. The military relies on Acumentrics for any equipment that is functional in harsh environments. The rugged UPS 2500 is a great example of a product the military is looking for. It provides 2500 volt amps of electrical power. It has the capability to be connected in parallel with N+1 redundancy. This is beneficial because parallel redundancy allows for the failure of a single UPS to be made up of the connections of the other UPSs. Control of parallel UPSs is normally managed using a primary and secondary arrangement. Primary controller is the brains of the system and determines operating parameters. The primary is where the UPS modules synchronize their outputs, share loads, and where their control information comes from. The current method requires complicated control wiring between UPS modules, as you can see on the right. The inconsistencies in manufacturing assembly result in parallel load failures. Our project motivation is to simplify this complicated design. To reduce the occurrence of faulty cables and to reduce the cost of manufacturing, we came up with our anticipated best outcome. This outcome is to combine the current two PCB modules that are built into the cable and integrate the newly designed PCB module inside the rugged UPS 2500. This PCB redesign will also include the reconstruction of the current cable. Our ABO is very close to being reached. Our PCB boards are in the process of being soldered, and there will be testing needed in the future. Here's a block diagram that shows the transition of taking the PCB boards out of the cable and into our UPSs. Some team key technical accomplishments included finding similarities and differences between the original primary and secondary PCB, building and testing hardware circuits, combining the primary and secondary circuits into a single module, as you can see on the right, and incorporating switches into our new PCB design. For details on my individual accomplishments, first, when I created a list of similarities and differences of the primary and secondary board inputs, this was necessary for the creation and redesign of the combined board to make sure that the board could be made as simple as possible. This was a low difficulty because I referenced the signal map on the right. For the bill of materials, it was necessary to find identical components similar to the ones used at Acumentrics to make sure that we had the most accurate readings. This was a medium difficulty because not all the components had a through-hole equivalent that was needed for breadboard testing. Because of this, that led me to my third and fourth accomplishments, which were soldering and testing continuity of my adapters. From there, I was able to combine the primary and secondary board into one design. I was able to test the circuit board for its functionality, and I also incorporated switches to establish the difference between using the primary section of the board versus the secondary section of the board. To summarize my key technical accomplishments, I redesigned the original schematic and cable connection points. I did this by incorporating switches into the new design. I also provided Rute Gidey, our PCB designer, guidance into my new design. Now I'll turn it over to Rute Gidey.
Here's another look at our block diagram of our proposed product. And what we intend on doing is having a combined PCB board in each of the UPSs so that when they're set up in parallel arrangements, the signals are just transmitting what's being taken out of one and what's being sent to the other instead of distinguishing what goes where within the cable. And this simplifies the cable a lot more. In terms of technical contributions, we first wanted to understand the differences between the primary and the secondary PCB module that we were provided with, and that was initially located within the cable. And once we understood the differences, we went on to combine them into a single control board. And this control board was built on a breadboard, and some streamlined testing was done on it, as well as some software testing through Eagle PCB Design. And once those were verified, we went on to create a schematic of the PCB on Pads Professional. And this new schematic implemented the use of connectors and switches to direct the signals on the control board instead of within the cable, so that reduced the job of the cable to just transmitting signals from one UPS to the next. Here's a look at our new schematic of the combined module. In addition to the primary and secondary components, there are connectors, which are located on the top left and right side of the first image. There's a connector for the signals that are coming from the computer board within the UPS. Then the other two connectors act as input and outputs for the signals located in the combined board. There are 7 dual SPDT switches being used to control the connectors, and their use is to route the signals to the proper locations when put in parallel lineup. This way, the UPSs know whether to act as a primary and a secondary. This schematic was reviewed and sent to a manufacturer to print into a 2x4 PCB board, but due to us not having enough time, we weren't able to complete the board and test its functionality, but we were able to populate it to a certain extent. And that is what you see at the bottom of the slide here. The economic impact of our design will provide a simpler cable solution that will require less time to make and easier functionality for the customer. The new cable will not require a custom cable like before, so it'll be much cheaper. And this will help the company with time and cost savings that could be reinvested into developing new technologies. We would like to say a big thank you to Bill Owens and Acumentrics for providing us with this wonderful opportunity. It was a great learning experience, very unique to what we were used to at this university. We'd also like to thank Dr. Sunak for being a huge motivator to our group by challenging us to do all we can and teaching us about discipline within the projects. Lastly, we would like to thank our technical directors, Brendan and Mike, for providing us with assistance and guidance as soon as possible whenever we stumbled on a problem throughout the year. Thank you for your time.